The stage was set with the resonance of applause as Bill Nye, the beloved science guy, stood before the crowd, his Presidential Medal of Freedom gleaming under the spotlights. This wasn't just his victory, he emphasized. It was a testament to the power of science itself. The medal symbolized the collective triumph of human curiosity and ingenuity, a reminder of how transformative discoveries could shape the very fabric of society. Yet, as the world celebrated science's past achievements, it was on the brink of an entirely new frontier. Quantum computing, once relegated to the realm of theoretical physics, was no longer a distant dream. It was becoming a tangible reality, a powerful tool that promised to revolutionize industries, solve problems previously thought insurmountable, and open doors to possibilities that seemed like science fiction only decades ago. The breakthroughs were undeniable. Companies like Google had taken quantum computing from abstract equations to functioning systems. Their advancements marked a new chapter in technological progress, a thrilling leap forward but also one fraught with uncertainty and concern. The difference between classical and quantum computing lay not just in scale, but in nature. Where classical computers relied on the binary system of zeros and ones, quantum computers operated with qubits capable of superposition, existing in multiple states simultaneously. This allowed for exponential increases in computational power, unlocking capabilities that classical systems could never match. The implications became glaringly evident when Google achieved quantum supremacy, solving a problem in mere minutes that would have taken the most advanced classical supercomputers an inconceivable amount of time. This milestone wasn't just an academic exercise, it signaled the dawn of real-world applications across fields like artificial intelligence, personalized medicine, and materials science. The potential was staggering, echoing the transformative power of the first quantum revolution. Government-funded research into quantum mechanics had once given rise to inventions like nuclear energy, GPS, lasers, and MRI technology. Now, quantum computing stood poised to deliver innovations just as revolutionary. But this was not a race without competitors. Around the globe, nations like China were pouring resources into quantum research, recognizing its potential not only for economic growth, but also for strategic dominance. The United States, however, risked losing ground. Stalled funding in 2024 had left the nation vulnerable, a stark contrast to the urgency with which other countries pursued quantum advancements. The race wasn't just for technological superiority, but for control over a future in which quantum computing could redefine the balance of power. With great power, however, came equally great risks. Among the most controversial developments was the God particle plugin, a term whispered in both awe and apprehension. This plugin represented the darker side of quantum potential, the ability to crack encryption, undermine global financial systems, and even develop unprecedented weapons. The ethical questions were as vast as the technology's capabilities. Could humanity wield this power responsibly, or would it fall victim to its own unchecked ambition? Bill Nye's voice carried a steady urgency as he addressed these concerns. Innovation, he argued, must be tempered with responsibility. Quantum computing had the potential to uplift humanity, but only if it was approached with care, regulation, and ethical foresight. The stakes were too high to allow recklessness or short-sightedness. He called for open discussions, global cooperation, and safeguards to ensure that quantum technology served as a force for good rather than a harbinger of chaos. The crowd listened, some with wonder and others with unease, as Nye's words hung in the air. Science had always been a double-edged sword, capable of both creation and destruction. The challenge now was to ensure that this newfound power was wielded wisely, that the future of quantum computing was one of progress, not peril. The God particle plugin had been revealed, and with it came the ultimate question. Could humanity rise to meet the responsibility of its own ingenuity?